To our college calculus, our class for today. We will continue with different derivatives, also differentiation of rules. Okay, today I will show you how work with that derivative of trigonometric function, and also I'm gonna show you what I mean the change of the rule, chain of the rule. Okay, chain of the rules. Okay, first of all, let me write we have some clue for our class today. We are talking about the f of x equals sine of x. Okay, this is the main idea in all our problems for today. So I will write some formulas here. We will have like formulas like this: limit of sine of this angle when this angle x angle, right, approach to 0 divided by the angle. So this is equals 1. This is one formula or rule that we have to memorize. This is a number 1. And in number 2, we will have a limit of cosine of this angle minus 1. Say is some rules. When this approach to 0, this is equals 0, right? V equals 0. So memorize these kind of formulas. All right, we have another one formula. Actually, this is a number 3. From number 3. From number 2, this right here. Number 1 right there. Number 2, number 3, number 1 over there. Number 2, number 4. Let's write number 4 here. We have the differential of differential x of sine of x equals cosine x. So it's some clues. Number 5, this is I will call the formulas for the numbers. Okay, differential of differential x. This is cosine x equals a negative sine x, right? And the last one that we will talk about is a differential x tan x is equals secant to the second power x. So these kind of formulas we have to understand. I'll memorize a little bit, right? Let me write the rules. Right now, I am talking about the derivative of trigonometric function. The first topic, we have two ones here. So the first one, let me write the derivative of trigonometric function. So derivative all right. So we have 6 formulas. I will write to write all formulas here. So it's very important. So this one, sine of x equals cos x, right? And the other side we have differential divided by x of cosecant of x equals negative cosecant x cotangent x. All right, this is another formula. This one, differential divided by differential x of cosine x equals sine x. Maybe I write it before, but just I would like to write these formulas because we are going to apply in our problems. This is secant x equals secant x tan x. And then the number 5, we have this one, tan x equals a secant to the second power x. Then right here, this side we will have the divided of dx cotangent x equals negative cosecant to the second power x. Okay, see the formulas? This is a derivative of trigonometric function. All these 6 we are going to apply in the next couple of problems, all right? So let me show you one problem. I will show some problems applying all these formulas. These formulas. Okay, we have to find this problem, differentiate y equals x to the second power sine x. Okay, this is our problem. So what is the solution? Our problem, we have to solve this problem applying all the rules that I show you. We have to use here the product, and we have to use aquí product rule, and the formula 4. 4. Remember, I write the numbers right here, the number 4 before. So if we work with that, it's very simple in this problem. Very simple. See, just apply the formula, and we will have dy, and then divided by dx equals x to the second power, and then d divided by dx, here multiplied by sine x plus sine x, divided by the differential of differential x times x to the second power. All right, see, if we simplify this, it's very simple. We will have x to the second power cosine x plus 2x sine x. That's it. Very simple problem, right? Okay, that's done. Let's go and then let me try to show you different kind of problems. So this one, differentiate of f of x, look at this, it's a little bit different, equals, let's write secant x divided by 1 plus tan x. That's the problem. Solution. Let's write the solution. How solve this problem? What kind of rule we need to apply here? So the quotient rules. Here the quotient rule, right? Quotient. The quotient rules. So we will have f prime. Remember, when you write the prime, it's also the same of x equals, let's write, it's gonna be long. So 1 plus, here we tan x, here d divided by dx of secant x, right, minus secant x d divided by x times 1 plus tan x by d over 1 plus tan x, all this to the second power. All right. As next step is simplify a little bit, right? We have to simplify. We simplify, we will have here 1 plus tan x, right? Then sec x tan x minus secant x times sec to the second power x divided by, again, just 1 plus tan x to the second power. So we continue. Simplify. Doing so here we will have sec x times tan x plus tan to the second power x minus secant to the second power x divided by 1 plus tan x to the second power. So that is continuous. So the next one is already sec x tan x minus 1 here divided by 1 plus tan x to the second power. That's it. That's the answer in this problem. So just apply the quotient rules. Just follow the directions and you got it, the answer. Let's go and apply more rules. Let's find the limit now. Not with this. So now we have to find limit of sine 7x divided by 4x when x approaches to 0. So this is our problem. The solution here, how find the solution? We have to apply the equation number 2. Remember, and the rules that I give it to you. Equation number 2 in this problem, and then we have to write the multiplication multiplying by 7. Okay, so equation 2. Let's write here. Equation 2. There's a clue for you, and then multiplying and divide by 7. So that's a clue to solve our problem. All right, so then let's do it. So we have now next step, sine 7x 4x equals 7 4, right? 7 4 sine or 7x 7x, I mean 4x right here. I mean 7x. Yeah, 7x. So here we have to write a note that I have to make the difference right here, right? Sine, look at this. Sine of 7x is different, all right? Not equals. Different of 7 sine x. And it is not the same, right? I write it. So, if we have, for instance, 0 here on the angle equals 7x, and then this angle approach to 0 as x approach to 0, right there. By equation 2, this is by equation Number 2, remember, check the question number 2 that I wrote before. So we will have then limit of sine 7x divided by 4x when x approaches to 0. So look at observation. So this is 7 divided by 4. When limit x approach to 7, here we will have a sine of 7x divided by 7x. Okay? So this will be equals 7a divided by 4, limit when x approaches to 0. Here is about sine of the angle divided by this angle. So it's equals 7/4 times 1 equals 7/4. 7/4. That's it. That's the answer, right? This is another problem, another question. So we are applying all the rules, derivative or trigonometric function. Let's talk about another problem, different this one. So let's write a limit of x cos x when here when x approaches to 0. So the solution, so always let me give it to how solve the problem. Solution. I don't want to write everything, just some clue for you. So we have to divide here numerator by x. Okay, if we do that, we will have, look at this, the process. I will write the process, all the process here. Limit when x approaches to 0 of x cotangent x is equals, I told you, limit of x cos x divided by sine x when x approaches to 0. So this will be, if we simplify this, we will have limit here of cos x when limit approach to 0. So divided by sine x divided by x. Here will be equals a limit of cos x when x approach to 0 divided by limit of sine x divided by x when x approach to 0, right? So this, if you simplify, you will have cos 0, 0, okay, divided by 1. So the answer here is equals 1, right? Cos equals 1. So this is by the rule. The rule, I write the rule by the continuity of cosine and equation 2. Equation 2, right? That's the way that we got this answer. So I'm trying to show you some of the rules that I wrote before applying in these problems. It's very important. Don't forget the properties or the rules here. We remember this unit is about the differentiate of rules. So now we talk about this kind of rule. Change rule. What I mean this. These chains of rules are is when we're talking about this formula. Let me write the formula here. This rule is f capital letter of x equals, so this is a not capital letter of g of x times g of x. This is the chain of rules. So if we write it in lane Nice notation, if y is equals f of u and u is equals g on x are both necessary rules. So then we have like this differentiation of the d to x equals and dy over du times du divided by dx. So this is kind of the rule this change rule. Also, this rule we are able to write it in this other way. We have to write like this. This is a number one rule. Number two, the rule number two as this way. Remember, of x if g of x times gx. Actually, we already wrote before. It's this one. That's the rule. This is the rule and number three. So the number three, this is a number three actually, the same. The notation 2, 1, or 3 is either one right there. So let's let me show you one problem applying with change rules. Or applying all rules. So find f x of x if f x is equals x to the second power plus 1. All right. The solution. What kind of equation we have to use? Here, the question that I write here before a few minutes. Okay. So equation. So just check what I mean the equation to. I write the number of the equation. All right. Then let's write here f of x equals f as compound right with x. We will have f and g of x. This is g of x, where we have here f of u equals square root u, and remember we applying the rules. Gx equals x to the second power plus 1. Now we have it there. Since f primes and the derivative here, u is going to be equals 1/2 u minus 1/2 right here to the exponent. So divided by 1 divided by 2 to the square of u, and also we will have g prime of x equals 2x. Okay, we have f capital letter of x equals here g of x times g prime of x. So this will be equals 1 right here, the numbers, 2 times to the square root of x to the second power plus 1 right there, times 2x equals x square root x to the second power plus 1. All right, that's a solution. Solution number 1. We have another solution to this. All right, because we have and that it is the same answer. It will be the same answer. The solution number 2. The solution number 2 is 2 solution. The number 2 solution using equation 3. Or the last one, or number 1. All right. If we let u equals x to the second power plus 1 and y equals square root u, then look at this. Now it is the same. Will be the same answer. We have dy du by dx equals 1 divided by 2 square root u. U times to 2x should be equals 1 to same thing, x to the second power plus 1 times 2x has to be the same answer, x square root x to the second power plus 1. See, we got it, the same answer. See, so let's write another problem with this one. Change of rules. Change of rules. I have a lot question. Before to solve this problem, I want to show you this kind of rule. The power rule combined. So the power rule, the power rule combined with the change rule. All right. If this is very important, n is any real number and u equals gx. Remember, I used it, so that is very important. Is then this is very important. We will have d divided by dx of u to the n power equals nu to the n minus 1, because sometimes we use this u divided by dx. So we use this rule a lot. So d divided by dx x to the n equals n. This is very important. Understand this rule, n minus 1. So times g prime to the x. So this is a rule. So check and try to memorize or understand the rule. I want to apply this rule in the next problem. Okay. So let's write find the derivative of the function. So we have this function here, t of t equals t minus 2 divided by 2t minus 1 to the n power. That's our problem. So what is the solution to our problem? Solution. As always, I give it to you some clue. Combine the power rule. So here we have to use power rule. See, already you know. And then change. We have to use chain rule. Quotient rule. So all those rules we have to use to solve our this problem. So started. We will have g prime of t equals 9, right? T minus 2, 2t minus 1 to the a power. D here we have dt times t minus 2 divided by 2t plus 1. All right? So this will be equals, it's very simple. All right, just apply the rule. 9 t minus 2 divided by 2t minus 1 to the a power here. So we will have here, 2t plus 1 here times 1 minus 2 times t minus 2 divided by 2t plus 1 to the second power. So we simplify this, we will have 45 here. 45 times t minus 2 to the 8th power divided by 2t plus 1 to the second power, right? No, not to the second power. Now, is here to the second power, he's going to be to the 10th power. All right? So that's it. That's it. That's the right answer. Okay, college calculus. Today we work with the derivative or trigonometric function and also the chain rule. It's different kind of problems we apply that the differential of rules. So thank you so much. Waiting for you for the next